Hello everyone and welcome back to the channel. In the last few videos we learned how to build AI agents using Spring AI. We created agents, integrated large language models and saw how they can answer questions and perform intelligent reasoning. But today let's think of a real world scenario. Imagine you're chatting with your AI assistant and you ask, "Hey, create a file called notes and store it inside my documents folder and write today's meeting notes into it." Or maybe you ask, "Read all the PDF from this directory and summarize them." Or perhaps send an email to John with yesterday's sales report. Or more even, fetch today's stock price from a third party API. Also, sometimes we expect, like if you're traveling, "Hey, assistant, book me a flight from Bombay to London." And these are very practical requests. This is what a user expects from a modern AI assistant. But here's the problem. A large language model cannot connect to your database. It cannot send mails. It cannot interact with the file system. It cannot connect to the GitHub repository. An LLM only generates text and it does not have any built-in ability to interact with the external systems. Okay, so all this are external systems. Okay, so the obvious question is, if you have ever wondered or maybe asked yourself, how does a chat GPT read files or cloud interact with GitHub, or how do AI applications connect to database, Slack or Google Drive or even local folders? And the answer is MCP, Model Context Protocol. So let's break down the MCP. So think MCP as a standard communication protocol, okay, between AI and external tools. So to access the database, access the email file system or any third party API or any other tool, you need some communication mechanism between your LLM and these tools. And MCP provides a way to communicate. So if you break down the name Model Context Protocol, so model refers to the AI model such as ChatGPT or Gemini or Cloud. Context refers to the external information or the external or the tools, you can say, or the capabilities that the model needs to perform various tasks. And protocol is refers to the rules or the communication rules, your between the AI application and the external tools. So the protocol contains like standard input output. Okay, if you're connecting to a local MCP client server or some streamable approach. So how would our architecture look like? So we have the Spring AI application. We give a prompt to the LLM. "Hey, create a file in the documents folder with so and so content." The LLM will start guessing. So let it not guess, but let it know that this is something beyond its capability. So further, it will send the request to the MCP client. Client will interact with the server. So we'll be having different MCP servers. We'll be having file system server. We'll be having GitHub server, Google Workspace server. Okay, so there are various servers available. So the MCP will check. Okay, it is requesting for files operation. So it will connect to file system MCP server, do the processing using some inbuilt tools and give back the response. So this is how the MCP works, or you can say the when we collaborate the LLM and the MCP client server. So let's understand this with an example. Okay, so I've created a Spring Boot application. in which I've added these dependencies: Spring Boot Startup Web, MCP Client, and Mr. AI. Okay, we'll go to MCP Client later. Okay. Um, so here, okay, now we'll create, okay, and in application.yaml, I've added this properties, Mr. LA API keys, and telling which chat model to use. Okay, if you have gone through my previous videos, this will be very much familiar for you all. So let's quickly create a controller. So we can call it as MCP controller. Okay, so let's create a controller. We'll mark it as at the rate rest, sorry, at the rate rest controller. Okay, and at the rate request mapping. Okay, we'll put slash API. Okay, so now, hmm, now we need a chat client, right, to interact or to provide a prompt. So private final chat client and chat client. Okay, so let's initialize this in the constructor. Now chat client will directly not be used. We need the builder unit. Okay, so and we can provide here chat client builder. Okay, and we can do chat client builder dot build. So we have initialized our chat client and it is ready to use. Now we'll create a post mapping at the rate post mapping with slash API slash chat is fine, right? Okay, public will take response entity of type string. Okay, and MCP chat. Okay, any method name would do. Okay, and at the rate request parameter we will take prompt and string prompt. Okay, okay, okay. Maybe it was a wrong input. Okay, so we have the chat client. So what we'll do, we'll take the chat client dot prompt. Okay, provide the prompt and dot call to get the prompt response and content to get the content of the response. Okay, and we'll store it to string response. Okay, and we'll return response entity dot okay of response. Okay, so we are good here. Let's run this. Okay, meanwhile in Postman, what I'll do, I'll create a post request, http colon slash localhost 8080 AI slash chat. Okay, and I have the prompt, so we'll take a prompt. Okay, so started MCP application. Now let's run this. Yeah, okay, slash API. Okay, fine. API slash chat. Okay, so here we are given prompt generate a Java code to print hello world and save the file as hello world.java. But what is done? Here's the sample Java program that prints hello world and instructions on how to save it as hello world Java. So you see here the LLM is telling us, okay, I've generated the code, but you go and save it by yourself. But that's not what we are expecting, right? We want the model to save it in the file system. So, so what we can do is we can make this LLM interact with the MCP client server, okay, which will further save the file. Now, how we can get those details is simply if you go to MCP model context protocol, okay, and they have their model context protocol website, okay, just scroll down directly to example servers, and if you see, you have they're given some sample references, okay. You have file system, you have git, memory, sequential thinking, okay. So as a quick start, we'll go to file system, okay, and in this git repo, if you're already in the file system, okay, if you scroll down, if you scroll down, okay, now these are the tools, okay, these are inbuilt tools which are already been provided. So you know, right, we create at the rate tools annotation, and then the agent decide which tool to call. So likewise, when you integrate or you implement this file system uh, server, once you start it, okay, these tools will be readily available. You just need to register the tools in the tools callback provider, okay. Now, how to use this? Okay, now you have the Docker setup. Okay, you have the npx. Okay, npx is nothing but a command, a node command. Okay, so what I'll do is I will take this npx. Okay, and let's keep it in some servers.json file. Okay, so now in source main resource. Okay, so I've already created this servers.json, and it's the same thing what we copied from here, MCP servers file system. Okay, and here I'm specifically telling AMCP interact with the file system on this location. Okay, now what we'll do, we'll go to the terminal, we'll create this drive. Okay, so inside MCP, uh, okay, so let me rm-r MCP, sorry. Okay, so if I do ls, there's nothing but all the project related files. Okay, now mkdir mcp. Okay, so ls, if I do ls, mcp, okay, mcp folder is created. I go inside mcp, okay, clear this, and I do pwd. So I get this current path, I take this current path, and I keep it over here. So to the file system, I'll tell the npc server, mcp server, to whatever the file related operations will be there will be done in this folder. Okay, you can even give the root folder, whichever folder you are right. Okay, or if you're on the server, say EC2 or something, then you mount a drive, you have the path, right, then you can provide that location as well. Okay, and if, okay, now if you just type go with npx, right, so sometimes what will happen, the IntelliJ, or while starting the server, the application might not able to run this command because it's a node command. Okay, now that's a dependency what you need, just a small minor dependency. You need to have node installed. Okay, and if you get server startup, okay, we'll see that as well. Okay, but before that, in application.yaml, we'll need to add an entry to tell the application to pick the servers.json. Okay, okay, so what we'll do is we'll take your MCP STDIO. Okay, now we are connecting to a local MCP server, so we'll just go with standard input output and servers configuration. Okay, class path will be servers.json. Okay, now this will be used to start the server when the application loads. Okay, so MCP Studio, okay, MCP Client and server configuration. Okay, now we are good. Okay, now as I mentioned, we'll just go to npx and we'll start the application. Okay. Okay. Failed to start process with command npx. Okay. Okay. Fine. So server is started or not? MPC server starting, but the server is not started. Okay. Failed to process command. So to validate this, what you can do is you can simply go to terminal CLS. Okay. First check npm hyphen v. npm is okay. So npx hyphen v. Okay, so we already have npx-v, we are getting the version. So npx is there in our system, but the application, while server startup, starting the MCP server, is not able to locate it, right? So let me just provide the path. Okay, now this is the path. If I go to my C program files node.js, we have the npx command. So I'm directly referring to the npx command location. Okay, so just make sure, keep a note. If you are facing server startup issue with respect to npx command cannot be found, there could be two issues, two things. Check whether node is installed, or if node is installed, locate for the npx.cmd file and give that file location. Okay, so now let's start again. Okay, so this folder is um, empty as of now. That's fine. Okay. Now, if you see here, MCP server starting, MCP server started. Oh, wow. We have connected to the MCP server. Okay. Now, MCP file system server running on STDIO. Okay. STDIO means again, it's a standard input output and uh, running on local systems. Okay. STDIO message. Okay. No sampling phone. Okay. This is all fine. And Tomcat is started MCP application. Okay. Everything is good. Now, moment of truth. Okay. Let's execute this command again. Okay, so what you'll think? Okay, here's a sample Java program that prints hello world along with instructions, blah 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 blah, steps to save the file. Uh, Refresh. Okay, it's not great. Okay, something is missing. Let's see. MCP IMPL. Let's go to terminal. Okay, let's see MCP IMPL, and we have MCP. Oh, okay. One thing I missed. Okay, one thing I missed. Okay, so yeah, so this is what happens. So see, I mentioned, and okay, let's scroll up. Okay, now yes, the catch. Okay, so I mentioned tools, right? And we need to register these tools. Okay, so how to register these tools is using tools callback, tool callback provider. Okay, and we can provide it as tool callback provider. Okay, yeah, this is what I was missing. Okay, and I need to tell my chat client, right, that refer to this default tools callback, and I can provide a tools callback provider. Okay, okay. Uh, yeah, now I think we are good. Let's try. So what this will do is tool callback provider. As you know, we create tools, right, with @tools annotation. So and we need to register those tools in order our agent to identify like what type of operation or what type of functioning we want to do. So let's run this again. Oh, great. And you see, we have hello world.java. So what's the response? Okay, it also successfully now you see it didn't give the code, right? I've successfully generated and saved the Java code to print hello world in a file name hello world.java inside the MCP directory. You can now compile it and run it using the following commands. Wow, amazing, right? Now the client, the model has started interacting with the local file system. Amazing. And we have the file created. Okay, let's open and see. Oh, cool. It has created a public class hello world with public static void main and sys out as hello world. Okay, hello world is what we all started, right, during our programming days. Print hello world. Okay, now, okay, I can tell this permanently delete hello world dot java file. And I can help you to trash or backup. Okay, so okay, now the thing is it cannot assist with permanently deleting because you have not given access to the recycle bin. Okay, if you give access to the C root, then maybe it can interact with the other folders as well. Okay, but we can do trash delete file system.java. Okay, so see, it has created dot trash. So, so is it? It is very well recognizable that this is a kind of a bin folder. Okay, fine. So our objective here was to tell LLM to interact with the file system, and do some processing on it. Okay, so there are various tools. Okay, if you go through these tools, right, you can read a file, list all the files. Okay, now even if I tell them, okay, uh, list all the files from the directory files hello world dot location. Okay, so uh, amazing, isn't it? So going ahead, we'll try to implement more such tools. Okay, we'll integrate more such servers to see like how we can create an email, or we can upload a file to the Google Drive, or maybe try to access some third-party API as well. So yeah, that's it for this session. If you like the video, if you have, please do like, share, and subscribe, and please do drop a comment.